today we have the chapter Basic Principles of Organic Chemistry. We know, students, in our 10th standard we have studied definition of organic chemistry. Organic chemistry is a very important branch of chemistry in which we study different classes or different compounds containing carbon. Carbon is the very essential element in organic chemistry. There is another branch which is called as inorganic chemistry, in which compounds having other elements than carbon are studied. In organic chemistry, we have a very important part in our today's lecture, that is classification of organic compounds. Students, we have studied so many organic compounds in our 9th standard, 10th standard and 11th standard so far. And it is very important to classify them as they are very large in number. It is said that total number of compounds other than carbon, total number of compounds of elements other than carbon are less than compounds of carbon. You know very well, reason is catenation. Students, carbon can form very large number of compounds. So that to classify these compounds, that is organic compounds, it is very important for us. We have different bases by which we can classify organic compounds. First basis is based on carbon skeleton. In today's lecture, we have to see on the basis of carbon skeleton how organic compounds are classified. Another basis we have that we will see in next lecture, that is based on functional groups. Definition of functional group, what is the meaning of homologous series, that we will see in our next lecture. But now, based on carbon skeleton, how to classify organic compounds we will see. Students, organic compounds mainly classified into two parts, that is aliphatic and cyclic. Students, aliphatic means carbon-carbon straight chain or carbon-carbon straight chain having branches. Means carbon-carbon straight chain compounds or carbon-carbon straight chain compounds having branches to it. That comes under aliphatic compounds. Another type is cyclic compound. Cyclic means ring. We can say closed chain. These compounds are also called as closed chain. Cyclic compounds or closed chain compounds. Aliphatic compounds are open chain compounds. They are open chain compounds. In closed chain or cyclic compounds, further classification is done as homocyclic compounds and heterocyclic compounds. Students, here one important thing we should consider, the meaning of homo and hetero. Homo means containing same element. Here the meaning is containing carbon as the constituent element of the ring. If you know the structure of benzene, students, next also we are going to see the benzene. But homocyclic, containing carbon as constituent element of the ring. Other than carbon, no any element present in the ring. Homocyclic. Another is heterocyclic. Heterocyclic means having any one element. Generally, it can be oxygen, it can be nitrogen, it can be sulfur in the ring other than carbon. Okay, carbon is already there, but one of the carbon in the ring is replaced by other element. Homocyclic compounds are further classified as alicyclic and aromatic. Students, alicyclic compounds means their properties, they are actually closed chain compounds other words, when you take the example of open chain or aliphatic compounds, first and last carbon, when first and last carbon is connected by single bond, these alicyclic compounds are formed. We will see the example also. Alicyclic compounds, aromatic compounds. Students, aromatic compounds. Previously, the meaning of aromatic, aroma means pleasant smell. Previously, definition of aromatic compound was compounds having aroma, means pleasant smell. That is called as aromatic compounds. Nowadays, this definition has changed. Nowadays, aromatic compounds should fulfill some criteria given by Buchane's rule. That is, they should have conjugated system, cyclic system, and should possess 4n plus 2 pi electrons. Okay, so here we will see the aromatic compounds example also. Our heterocyclic compounds are further classified as heterocyclic aromatic. Heterocyclic aromatic means their structure resembles with benzene ring, and heterocyclic non-aromatic. Heterocyclic non-aromatic means they contains other element than carbon, and they are not resembling their structure with benzene. Students, aromatic compounds. I told you, in aromatic compounds, very important part is having benzene ring in it. If structure of aromatic compound resembles with benzene ring, such aromatic compound is called as benzenoid. If structure of aromatic compound do not resemble with benzene ring, such compound is called as non-benzenoid. They are aromatic but non-benzenoid. And we have examples of some of the types. First example, I had told you that alicyclic means their properties resembling with aliphatic compounds, but they are of the type of homocyclic. Students, we know the example of butane. Butane comes under the aliphatic. Please see CH3, CH2, CH2, CH3. This is butane. Okay, I told you compounds of aliphatic, their properties resembles with alicyclic. When I will connect first and last carbon of butane, what I will get? Please see. Alicyclic will get CH2, 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 CH2 in this carbon. Means, in short, this compound will be like this. This will be called as cyclobutane. Example of alicyclic. Alicyclic means it is the part of homocyclic. Carbon, 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 carbon at the corner of the ring. We have aromatic. I will write the example of aromatic here only because one of the type of aromatic compound is benzenoid. Please see, students. Please see, hexagonal ring, that is cyclic structure, and single bond, double bond, single bond, double bond, single bond, double bond. It is alternative single bond, double bond structure. In other words, it is also called as conjugated system. This is also called as conjugated system. Non-benzenoids. Students, non-benzenoid structure is, example is the 1, 2, 3, 4, 5, 6, 7. 7-membered ring having alternate double bond is the example of non-benzenoid aromatic. It is aromatic, but it is not resembling with benzene. Benzene contains 6-membered ring. This is 7-membered ring. Another example we have of heterocyclic aromatic. Students, they are aromatic, but heterocyclic. Heterocyclic means containing one atom other than carbon. Very famous example we have pyridine. If you know the benzene, just one carbon at the bottom of benzene is replaced by nitrogen, and newly formed compound is called as pyridine. This is the structure of pyridine. This is the structure of pyridine. And one more example containing heterocyclic non-aromatic compound tetrahydrofuran. Example is tetrahydrofuran. Tetrahydrofuran. Which is also called as THF. This is pyridine. Okay, students, this was the classification of organic compounds based on carbon skeleton. Further classification based on functional group we will see in next lecture.